Okay. Uh, this is the first unit, cellular concept and system design fundamentals. First, we have to know that what is a cellular. Nowadays, we are using this computer networking, cellular networking, cell phones, mobile phone, smartphone, all these uh, phones use this cellular technology, wireless phone, cellular technology. So, how we are communicate each other using the cellular technology in a previous olden days, in the previous technology, we are using this PSTN, private telecommunication switching system. This is the telephone booth. We need to connect to the main exchange. We need to communicate to the main exchange using a cable. Then we have to dial the numbers. Then it goes to the main switching centers using the cables. Then we have to dial the number, and then the switching center switch the number to the corresponding destinations. So this is the olden technology. But in today technology, we are using this cellular technology, wireless technology, and then we can communicate each other using the wireless. Okay, using the wireless. So how we are going to communicate using the wireless in this technology? And also there are different types of the communication system. First G is there, first generation technology, and second generation 2G communications, 3G communications. Now we are using the 4G and 5G also coming up, and then the latest one is the 6G also coming up. Okay, supposed to coming up. So there are different types of technology used in this cellular networks, cellular network. Let's move to the next slide. Frequency, frequency reusing in the cellular technology. Before this frequency technology, let me, can you see this frequency reused cell?
Yes, sir.
Can you see my
Uh,
presentation?
yes,
Okay,
yes, sir.
this is the example of the cell. Okay, these are the cell. Okay, these are the cell. C, E, G, D, all these things are the cell. So all this in this cellular technology, all these networks are divided into a cell. Okay, divided network into a cell. Then if we go into a particular cell, then we can use the network. We can use the network. But one more thing, each and every service providers having their own signal, and then the receiver. Without the SIM card, you cannot use the cell network, right? You have to insert your SIM card. This is the subscriber module. Okay, subscriber identification module. Without these subscriber identification modules, you cannot use the mobile network. You are not authenticated to use the cell network and the communication channel. So you need to insert your SIM card, and once it insert the SIM card, and then the registered SIM card available in the cell, then you can use the cell. You can use the network. You can use the network. So the basic idea is this: within a cell, we have a different types of spectrum, signal spectrum. So uh, let's say one example. In isol, if we have only one cell, then we need a high frequency to cover the whole city. Only one cell for isol, then we need a very high signal spectrum, very high signal spectrum. and it needs to cover the whole city of Aizawl. Then if we set up like this, it create the problem for the human being if it's generated high frequency. So what is the purpose of the cell? The purpose of the cell is that instead of using a very high transmission tower and a very high frequency, then the whole city, Aizawl city, is divided into a different types of cell with a low frequency. Okay, with a low frequency, then it's cover a small cell. Then we can cover we can cover different types of area using a cell, and also it's needed to transmit a very low power to cover the small area of cell. Okay, small area of cell. This is the concept of the cell. Let's go back to the frequency reused. Okay, I hope that you clear the cell, right? What is a cell? Did you clear the meaning of cell?
Can you repeat a little bit?
Cell is a how to say this as the smaller area of the mobile communications, smaller covered area. Say suppose in let's see, in the city of Aizawl, if we did not sell, then we need to transmit a very high frequency to cover the whole city. Okay, using the single tower, one tower. Okay, only one tower with a very high frequency. But if we transmit a very high frequency, then this is very harmful for the human being. Okay, so regulatory board does not allow to transmit a very high frequency. This is very harmful for a human being. That's why it's divided into a smaller cell. Okay, this to cover the city, then it's converted into a very small cell. Okay, this is called the cellular network. Okay, so very small cell, and every cell having a tower to cover the area. That's why we see the different types of cell in our city, right? So different types of tower. Okay, you see the mobile tower, right?
Yes, sir.
So this mobile tower cover a different types of cell. Okay, in the city, and also this tower is depend on the service provider. Okay, service provider having different type of cell. Okay, so different type of cell. Then this coverage area is called the cell. Okay, is it clear?
Yes, sir.
Yes, sir.
Okay. Did you see my slide frequency reuse?
Yes, sir.
Yes, sir.
Okay. Let's see this frequency reuse. What is frequency reuse? Frequency reuse is the schemes in which allocations are reuse of channel throughout a coverage region is done. Coverage region means the cell. Okay. In a city or in a different types of metropolitan area, they have a different types of cell. So in these different types of cells, we need to have a frequency reuse. Means in the area A, let me go to the next one, the next slide. Did you see this cell?
Yes,
Yes,
sir.
sir.
This graphic. Okay, in this graphic we have a different types of alphabet level, right? Alphabet A, F, E, D, C, B, G, right? Here we have a cell, right? Here we have a cell A, B, C, D, E, F, G. We have a cell of A, B, C, D, E, F, G. This is the cell. Okay, so within this cell we have to reuse the frequency in another area. So here we have a cell A, and here in the different types in the different area we have a cell A, right? The same cell, right? Replica of this cell means the same frequency used in this cell in another area. And also in this area, also in this cell also, we have a same frequency, same cell at compared to the compare with the cell A in another cluster. We will explain this, what is a cluster also. So this is called the frequency reuse. Is it clear? Frequency reuse.
Yes, sir.
Did you clear?
So,
So within a cell, if we use a different types of cell, say suppose I'm having the 30 numbers of cell in a city. So in this 30 number of cells, if we use a different cell for this 30, then it will become exhaust. Our frequency will become exhaust. Okay, will become exhaust. So, and also the types of cell is not a good technology. So we have to reuse it, the frequency from one cell to another cell. Okay, but the thing is that it should not be how to say, the frequency should not be collide. Okay, the frequency should not be collide, so it should not be in the adjacent cell. Okay, the same frequency should not be in the adjacent cell. So here in the frequency reuse is a schemes in which allocation and reuse the channel frequency throughout the coverage region is done. Each cell-based station is allocated as a group of radio or F frequency subband to be used within a small geographical area known as a cell. I already explained, known as a cell. Then a shape of the cell is hexagonal. Why we are using hexagonal for explaining the cell? Hexagonal is the how to say, the shape approved for identifying the cell. Let me share my whiteboard right now. Okay, here, did you see my whiteboard right now? Did you see my whiteboard?
No, sir.
It's not coming.
No, sir.
I can see now. So,
Can you see my whiteboard?
yes, sir.
No, sir.
No.
Kan suat kat kain rock.
Whiteboard kan em?
Yes, sir.
Motor. Let me explain this. So what is the why we they use this hexagonal for identifying the cell? Here we have a hexagonal, one hexagonal, and one more hexagonal here. So here if we put the tower here at center, then the distance is almost same in the hexagonal. Then there is no free space between the two hexagonal. So here if we join another hexagonal, then here we can join it, and also here we can join it another hexagonal. Then there is no space between this hexagonal. So hexagonal is very good for identifying the cell. Here we can join another hexagonal also like this, and here we can create another hexagonal also, and here also we can make it another hexagonal like this. Okay, then here we can have a tower in each and every hexagonal area. Then in between the hexagonal hexagonal, in between this each and every hexagonal there is no space. Say suppose if we want to identify the cell using the circle, here this is the circle, then here we have one more circle here, and if we tight up this one, and if we make another cell here, then here at the middle we have a gap, right? We have a gap, right? Then it cannot cover the cell using this. To overcome this one, to overcome this cell, we have to overlap each and every cell. We have to overlapping. So if we overlapping, then the frequency is it's overlap. It's collide with each other. So we cannot use this circle for identifying the cell. Then also we cannot use this this wall also is not possible to use this one. Based on this, if we put the tower at the middle of this point, then this is too far away, and this is too near, and this is too far away. And here in the circle, if we put the tower at the middle, then it's okay. The radius is same to each and every corner. Radius same, but in the cell cover area, there are some collision and free space in between this. But in the hexagonal, that the distance is almost same, and not exactly same, is almost same to each and every edges of this hexagonal from the center, and also to combine with other cell, there is no free space between the hexagons in this hexagonal. Is it clear, this one? Why we use this hexagonal? Any question?
So actually, we cannot able to see the whiteboard. Whatever you explain.
You cannot see.
Yes, sir.
Can you see my presentation right now? Can you see my presentation?
Yes,
Yes, sir.
frequency reuse, that one we can see.
That one you can see. Okay. In this, let me write. Can you see what I'm writing here?
No, sir.
Yes, sir.
Can you see
Yes,
what
sir.
I'm writing on my presentation? Okay. This is the example of the hexagonal. Okay. This is the hexagonal. Let me remove. Let me explain it. What is the use of the hexagonal and all these things? Screen. Okay, this is the example of hexagonal. If you want to make it the cell, then here this is the center. If we put the tower at the center, and also here if we want to make another cell, then we can extend that to this, and also here we can extend that to another cell, and we can extend that to another cell again, like a beehive, right? Phôi buồng đeo khan thì mấy rất tiếc em.
Yes,
Phôi
sir.
buồng đeo khan thì khan cell là khan in zoom thì nani. That's we can join it to a different types of cell here. Okay, it's like this. Okay, this is the hexagonal type of cell. Then there is no space between cell and cell. Can space on thelo hexagonal. So in rem com chat vectani. Until nan kamin lo ta se circle ta se circle a chuan a center hian until nan to no data ila a distance su radius between ang vekang tapo hian distance hi a in ang veke chu kan ti thelo wa ma se I a in an dana hi atam. Example, for example, square a chuan sa circle a chuan anin ang thapa ama ro chu heng circle cell pathum te hi da khom tai la alai hen free space om tat many in thathem in muthem ka thil zia kha
Yes, sir.
alai hen space om tat many area na cover thelo kha aniang tro ball mum pathum hi da khom taula alai all among tro if we club together all the three balls, okay, three balls together, then you have a free space at the center, right?
Yes, sir.
Okay, then it cannot cover by using the circle, right? So for covering this free space, we have to overlap the ball like this. Then here, overlapping area is there. Do you understand this one?
Yes, sir.
So why we are using this hexagonal in this cellular technology, that there is no space between the cell. Number one, okay, there is no
Yes, sir.
space between the cell, and also there is no overlapping. Okay, there is no
Yes.
overlapping, and also if we put a center tower in each and every hexagonal, then the radius of the edge is almost same, not exactly same like a circle. Okay, the distance is almost acceptable distance. Okay, say
Yes,
suppose
sir.
if we are using this square, if we put the tower here, then it is too far away from the center and it is too near. Okay, the
Yes,
radius,
sir.
we can, if we say the radius is too near and too far, so this is not applicable. But if we put together, then there is no issue in this overlapping and then the space between the cell. But if we put the cell in the middle, then distance is very much different as compared to this hexagonal. Okay, and if we use this triangle, then here triangle is here, here, here. The center point is completely the distance is very much different with uh, hexagonal and also square. Okay, but if we want to put together this triangle, then there is no issue, there is no space and all, we can put it like together in the triangle. Then cell distance and cell spacing, there is no issue. But from the center point, the edges of the cell is much different with other edges. So these are the thing in this hexagonal. Why we are using this hexagonal in the cell? I already explained this one. I hope that you clear this one, right?
Yes, sir.
Okay. Okay. Let's go to the next point. The process of selecting, allocating all the frequency subband for all the cellular base stations within the systems is called the frequency reuse as or frequency planning. So selecting and allocating of frequency subbands, frequency reusing in a cellular base station. Uh, Base station. Let me explain the base station first. Do you know what is a base station? Anyone knows what is base station?
No, sir.
Anyone knows? Say suppose this is my, can you read? Very difficult to write
Yes, sir.
in this PowerPoint presentations. We cannot use the whiteboard. You cannot see my whiteboard. Okay, the first area. This area is called your mobile device. Okay,
Yes,
this
sir.
is your mobile device. Your mobile device get the signal from the BS base station. Okay, base stations. Your mobile device receive a signal and transmit the signals, send and receive your voice communication, your data communications. Right now, also you're using the 4G connections for viewing my lecture, right?
Yes, sir.
Okay, so you can receive, send and receive data packet and your voice packet, everything through this mobile device using the base stations. And uh, nearby this base terminal stations, we have a BSC base switching center. Okay, nearby this we have a small house. In this tower we have a small cabin or a small tower. This is the base switching center, and this is the BTS base terminal station, and all these things are the BS base stations. Is it clear?
Yes, sir.
Yes, sir.
And these base stations communicate the MS, Mobile Switching Center, or MSC, MS or MSC. This is the main switching center. MSC is the main switching center. So if you dial the number, then if BTS can reroute this dial number, then it reroute to another BTS, or it cannot reroute this call into another BTS, then is sent to the MS. Okay, mobile switching centers, and these mobile switching centers register your home locations. You are in the roaming, or you are in the switch off mode, or you are in a different locations. Okay, and also your billing system, your packet billing. Now also you're watching my lecture using the 3G. All your data is calculated based on the packet you consume. Then it reduce your balance, your internet balance. All these things done in the MS. Okay, mobile switching center. And the switching and transmitting the frequency, the channel, everything done in the BS base station. And the last one is your mobile device. Your mobile device is the main communicating equipment for the personnel who is using the services. Okay, I hope that you clear this point, up to this.
Yes, sir.
Okay, very important to make equations. Otherwise, if you do not understand what is BS and what is the mobile station MS and what is the MSC, who is that guy? Lal mo naman. Lal mo naman. Lal mo naman ka aron lut siya mi ito na kan. At suwag lang halam ya. Lal mo naman karon, lal mo naman maral tayo ron join siya mi ito na kan. Aral mo naman. Ito nga sa tayo lang. Okay, anyway, what is the base stations? You already know what is the MS mobile station and what is the MSC mobile switching centers. I hope that you already know this one. And then the what is frequency reuse or frequency plannings? You already understand, right? Frequency reuse, the basic idea. Do you understand the basic idea of frequency reuse?
Yes, sir.
Yes, sir.
Yes or no? Som
Yes, sir.
tuangi.
Yes, sir.
Okay. Rajeshwar,
Yes, sir.
do you understand what is the frequency reuse?
Yes, sir.
Okay, so in each and every cells, if we want to use different frequency, say suppose I'm having the 50 number of cell for covering isol area, then we have to make 50 number of different frequencies. So it's create a problem. Then if we implement frequency reuse, then instead of having 50 different frequency, then we can do it using 25 frequency. We can reuse one cell frequency to another cell without colliding. Then we can reuse it the frequency. Okay, let's go to the next point. Silent feature of the frequency reuse. Frequency reuse improve the spectral efficiency and signal quality. Spectral efficiency is make some improvement in the frequency efficiency. Frequency reuse classical scheme propose the GSM systems offer a protection against the interference. That's why I'm telling you that if we collide each other, the frequency, then it will make some interference with each other. So it should not be interference with other frequency. That's why we have to use in the different locations, not in the adjacent, not use in the side by side. Okay, not into the another side, adjacent side. The next cell, we cannot reuse the frequency in the next cell. It should be in a different cell. So different cell, we'll explain it in the next slide. The number of times of the frequency can be reused and is depend on the tolerance capacity and the radio channel from the nearby transmitter that is using the same frequency, using the same frequencies. In frequency reuse schemes, total bandwidth is divided into different sub bandwidth that are used by the cell. Okay, in frequency reuse scheme, total bandwidth is divided into different subband. Total bandwidth means the total area coverage. Okay, total area coverage by the different type of cell. Different type of cell is divided into the, this is the total bandwidth divided into the subband that are used by the cell frequency cells that are used by the cells. Frequency reuse scheme allows WiMAX systems operators to reuse the same frequency at different cell sites. So frequency reuse is in the WiMAX and also in the GSM. Okay, GSM system. Global system mobile communications, GSM, use this type of technology. Okay, let's move to the frequency reusing again. The designed effective of early mobile radio systems was to achieve large coverage area by using single high power or tall tower. Okay, I already explained that. In the olden technology, earlier technology, mobile technology, they implement a very high tower and transmitted a very high power signal. So these very high power signals create some effect in our human being, human body, in our cell. So this is regulated right now. Then this technology, high tower and high power transmitter technology, to overcome this, we have a drawback. Any less number of cells can be handled simultaneously over a large geographical region, and then the regulatory organizations can allocate spectrum for increasing demand of mobile users. So there, these drawbacks leads ways to restructure the cellular architecture. So there's lots of demand in our cellular technology, and also some regulatory boards regulate that not to transmit the very high power from the single tower. So to overcome this technique, thus the high single high power antenna are replaced with many low power antenna. So without using a single high tower to cover a single city or metro city, that is divided into a small tower with low antenna, with low transmitting antenna. It's providing coverage to small regions called a cell. Okay, in the last class I already explained. This is called a cell. Large tower, high tower, high power antenna. This is divided into a very small antenna with low power antenna and less coverage area. This is called a cell. Okay. So each base stations will be allocated a set of channel to manage call, and the nearby base stations are allocated a set of channel so as to avoid interference. So each base station BS will be allocated a set of channels to manage call. So each base stations are located a channel. Channel means a different frequency, different types of frequency. In the olden TV technology also, we have a different channels. We can tune to each and every channel. If you want to use, if you want to view ESPN or Star Sport or movies, Star movies, then you have to tune to the particular channel. You have to tune to the particular frequency, then you can watch the video, the TV informations. Like this, each and every base stations are allocated a channel, a frequency to manage calls, and the nearby base stations or allocated a different set of channel so as to avoid the interference. So if they use a same channel to each and every base stations, then it will become interference with each others. It will collide with others. Then you cannot communicate. Then you cannot make the calls. Because of this, to avoid the interference, then we need a different channels. Doing so will result in a spectrum scarcity within a small regions. This problem is addressed by a concept called frequency reusing or frequency planning. Let's go to the next point. The frequency represents the concept of cellular frequency reuse. This figure represents the concept of cellular frequency reuse, where cells labeled with some letters use same frequency group. Okay, here in this cell, we label this A, and up to this here, we label A again. Down there, we have a label of A. Okay, we have a different types of label here. Then this label A alphabet, same label, use the same frequency reusing. It's identify the frequency reusing. Hexagonal cell shape is universally used for representing a cell because they closely appropriate a circle, and also they permit easy and manageable analysis of the cellular system. The actual radio coverage in a cellular system is called the footprint, which are determined by the field measurement and propagations prediction models. So the actual radio coverage in a cell, the actual radio coverage in a cell A, or maybe a cell B, or maybe a cell B, is called the footprint of this particular cell. If we say the cell A, then cell A footprint is this particular cell. This is the footprint, which are determined by the field measurement and the propagations prediction models. Okay, here these cells can be of types. The cell can be of two types. Number one is TC, means base station are placed at the center of the cell. Base station means the main antenna are placed at the center of the cell. And EEC means edge excited cell, means base station, the antenna, and the BSC are placed at the edge of the cell. Edge means atlanga, cell klanga, cell khan, anda tinani tower ka, cell tower ka, base station kandani. If it is the CC, then it lays at the center of the cell. Is it clear?
Yes, sir.
Any question?
No, sir.
Okay. Let's move to the next slide. Understanding frequency reusing concept. How we are going to understand how to understand the frequency reusing? Let us consider S. In long poem to nak say in nang mani akan lang em.
Yes, sir.
Yes, sir.
Lang tro. Let us consider S, total available duplex channel, duplex, simplex, full duplex, interesting em.
No, sir.
Interesting em. Interesting lo mo. Duplex, simplex, full duplex, interesting lo mo. So ito, interesting em.
No, sir.
No.
No, sir.
Okay. Duplex means what? Duplex means one-way communications. It cannot revert it back. In the TV communication also, it transmits the signal from the service provider, operator, local operator. Then it transmits the signals to our TV. Then we watch the movies. We can watch the movie. We can watch the live football, and also we can watch different types of serials and all these things. But we cannot communicate back to the service provider. This is called a duplex, one-way communication. Simplex. What is the meaning of simplex? Simplex is the two-way communications, but not at the same time. If you communicate using the walkie-talkie, WT set, one person's saying, then another person's needed to switch off the microphone. Then it's talk. Then after it's complete, it says over. Then after it's said over, then another party can communicate to the same person. So this is the two-way communications, but not at the same time. This is called the simplex. And the last one is the full duplex. Full duplex means full communications, both communications, both sides can communicate at the same time. Okay, this is called the full duplex. In our telephone conversation also, where someone's speaking, then you can speak. Okay, where someone's talking, then you can talk also. So this is the full duplex. Is it clear? What is duplex, simplex, and full duplex? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Let's consider S total number of duplex available. Duplex available means one-way communication channel. Availability is called S. K means its cells is located a group of K channel. So its cells is located a frequency. Okay, frequency channels, frequency group channel. Then K less than S. K should be less than S. Find this S channel. S channel means duplex channels are be divided among n cell into unique and this joint channel group. Then the total number of the radio channels available in the express as the S equal to K multiplied by N. K means what? K is the cell is created as a group. Okay, group of channels. Multiplied by N is called the S, total available duplex channel. The N is the collective number of the cells use a complete set of availability frequencies called the clusters. So N is the collective number of cell use a complete set of availability number is called a cluster. Then what is a cluster? Let me explain it here. What is a cluster? Let me highlight the cluster in a green. This area is called a cluster. Let's say this is the cluster A. This is the cluster B. And this is the cluster C. Okay, here we have ABC cluster. Green cluster is A, and blue cluster is the B, and C cluster is the purple. So here we have different types of cluster, and each and every clusters having a replica of the frequency, of different adjacent cluster, but it doesn't collide. Okay, the frequency not collides. It does not intercept it. We can reuse it, the frequency. So what is a cluster? The group of cell is called a cluster. Okay. If a cluster is repeated for M, okay, if the cluster is repeated for M, here we have a cluster A, here we have a cluster B, here we have a cluster C. So cluster A is the replica of, cluster B is the replica of cluster A, we can say it. And A also the replica of cluster B, the same thing. A is the replica of C, or maybe C is the replica of A, but it doesn't collide it with each other. So here, this is the, if a cluster is repeated for M number of times in the system, then the total number of duplex channel C can be expressed. So how to calculate the duplex channel of the C? Okay, Duplex is the C. How to calculate this one? C is equal to mk multiplied by n. K multiplied by n means S. Okay. S is equal to K multiplied by n. And M is the what? Number of times. Okay, in a system. Cluster, number of cluster in a system. So M Kn we can replace by S, then C is equal to Ms. Okay, M means number of cluster. S means what? S means channels. Okay, channels are divided among the cell. Okay, then this is the N. The number of radio channel available is expressed as the S. So this will become the after multiplying this one, then here we'll get the duplex channels. N is typically called as the cluster size. N is generally given by the N is equal to I2 plus Ij plus J square. Okay, power 2. Or I square plus Ij plus J square. This will come the number of cluster. Okay, number of cluster size. Sorry, not the number. The size of the cluster. How many cells should be created inside the cluster? This will be calculated by the N. Okay. N is equal to I square plus Ij plus J square. I and J is nothing, but this is the non-negative number. It should be a positive number. This non-negative number. So we can give any number, positive number. Usually N takes the value such as 4, 7 or this negative number. Okay. Larger cluster size indicates radio between the cell radius and distance between the core channel cell are small. Larger cluster size indicates what? Ratio. Okay, the ratio in the cell radius. Just create the ratio between the cell radius and distance between core channel. Core channel means a replica. The replication of the reusability, the reuse frequency of a different cell. Okay. Small cluster size indicates the core channel cells are located much closer to each other. If the cluster size is small, then it closer to the frequency reuse cell. Okay, it's closer. Okay, it's closer to between the replica frequency. Then to find the nearest core channel neighbor of the particular cell, we have to move to this example. Okay, we have we move I cell along any chains of this hexagons. Turn 60-degree counterclockwise and move J cell. So following the figures, let's assume that I is 3 and J is true. Okay, let's see here. I is equal to 3 and J is equal to 2. Then if we implement this, then is equal to class equal to 3 and j is equal to 2. Then we in how to identify this one. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 cell in a cluster. So this is for you to calculate. So will come from the I value and a j value. So I should be the negative number. Okay, you can put the negative number. So to find the nearest co-channel, frequency reuse channel, how we are going to do? Move I cell. Okay, what is I? 3. Okay, move I cell 3 along any chain of hexagon. Along any chains of hexagon. Okay, I cell and turn 30-degree counterclockwise and move value. What is the J value? J. Here, this is the center of this cell. Let's count from here, starting from here. Okay, this is the originated cell. Let's count from here. What is number of I value? I value is 3. Okay, 1, 2, 3. Okay, 3 is going up to 3 and turn to the 90-degree. 60-degree. It goes back to the 60-degree, then goes with 60-degree and move to the J value. J is 2. Okay, 1, 2. Then this is the replica of this cell. Okay, the same thing. 1, 2, 3. Turn to 60-degree. 1, 2. Then this is the replica of this. The same thing. Cell 15. How to replicate this cell 15? 1, 2, 3. Turn to 16-degree. 1, 2. Maybe somewhere here. Here it will come this 15. Okay, 15 replica. Like this, we can calculate the cell. Okay, let's count this one. 5 cell. 1, 2, 3. 90-degree. 1, 2. Maybe somewhere around here. Okay. Then here we have the 5th replica. Is it clear, this one? On the question?
I think that's clear, sir.
Any question?
No, sir.
Okay, this is the frequency reusing concept. How we are going to reuse the frequency. Let me recap this one. You have to understand the first unit. Otherwise, if you don't understand one, then it will be difficult. The chance all these things. What is cluster? The cluster is the combinations of cells. Okay, and we can replicate each and every cluster to each and every in our cellular areas, cell coverage area, in our cellular network. Then how to calculate the number of cell, number of cluster, number of these joined group. Then using this formula, we can calculate S is equal to total number of variable of duplex. Duplex is the one-way communications. Then here in this K is the cell allocated group of the K channels. K should be less than should be less than, okay, K should be less than the S. Okay, S is the duplex channel. And how to calculate the radio channels availability? S is equal to K multiplied by N. And how to calculate the total number of duplex channels? That's C is equal to M is, what is M? M we already know. And what is S we already know. Then how to calculate the total number of cell within a cluster? Then this is calculated by using the N, by using the N square. Sorry, N is equal to I square plus ij plus j square. By using this, we can calculate. Then we can have the output. Okay, we can have the output. If we have the larger size cluster, then the cell reusability, that the cell cannot be closer. The frequency reuses cannot become closer. The interference chance is very less. If it's too small the cluster, then the interference chance is very high in the small cluster. Okay. Then how to find out the cell neighbor, all the co-channel neighbor, all the replica of the frequency, replica of the cell. Move I cell along any chain of hexagons, turn 60 degree counterclockwise, and move in the J cell. Okay, these are the things. Okay, that's all for today. Let me who is absent today? Let me read out. Oral monoma or vanal floa. Vanal chan chui and kakomha. Adikem present lo no mem kata khan. Attendance da lo no mem.
Sir, Vanal
Okay.
Chan Chui ka
Vanal chan chui.
Oral monoma.
Huh?
Oral monoma.
Oral monoma ngatingi ron balut lai ve.
Oh, sorry, son. Kan hatokon bak lai tuka.
I thau chaw ni ma.
Oh.
Muchugin na loi lo ngai thak.
Ai.
Hmm?
So harta.
Okay, that's all for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.